Jonathan Ballon is Intel Vice President in the Internet of Things Group. He is here with us today. Please join me in welcoming Jonathan Ballon.
We're back once again. It's great to see everybody here at the Intel Partner Connect meeting. And if you had the same level of excitement that I do from that video and from the opportunity that IoT has presented over the last several years, it's just going to get bigger, because what's fueling these IoT use cases and the growth in this business is AI. And what we're going to talk about over the next few minutes is the opportunity that exists for all of us to participate in. We're going to go into the investments that Intel is making in our product portfolio, into technologies, and into you, our channel partners, our system integrator, ISVs, and our entire ecosystem in the form of partner programs and capabilities that we're going to bring to you to fuel your growth. Personally, I believe that the Internet of Things and artificial intelligence is the single greatest technology-enabled transformation that we will experience in our lifetimes. And so whether you're here to change the world, or you're here because of the tremendous business opportunity that it presents, you're at the right place. Because Intel is at the foundation of both innovation and growth in this market, and we're going to explore that over the next few minutes. Let's jump right in and take a quick look at what's happened over the last year, because together we crushed it. We grew 20% year on year in 2017 in this market. And if you look back over the last 8 years, together, Intel and our ecosystem have grown twice our competitors. And you know, when you look at the reasons why our customers are choosing Intel architectures, it's actually reinforcing of our strategy, because we believe the market is moving to us. We believe that more and more compute is going to happen in a distributed computing environment, with things happening at the edge of the network all the way back into the data center or cloud. More and more analytics are going to be happening in an end-to-end environment where we're inferring things at the edge and we're training our data sets in the cloud. And when you look at this growth that we've experienced together, we put together a program about 3 years ago called the Architectural Conversion Program. And really what it was a set of tools and capabilities to allow you to move your customers from a competitive architecture onto Intel. And in 2017, 13% of our designs were actually designs that migrated from a competitive design to Intel. And when you talk to customers about the reason why they're doing that, of course the overarching reason is because they want higher performance. But they also want to lower their cost of development. They want to speed their time to market. And there's a lot of capabilities and functionality in the form of technology that we're embedding into our roadmap that they're desperate for. And we're going to talk about that. In fact, this architectural conversion program was over $650 million worth of designs in 2017. And over the course of this 3-year period that we've had it in play, over $1.5 billion of designs. These are really hard to win. They're tough. These are customers that have already deployed 1 or 2 iterations of a product, and moving it and migrating it is expensive. But they're doing it for good reason, and we think it reinforces our strategy. Let's talk about what some of those pillars are. First, IoT is going mainstream. We have globally over 2/3 of companies have at least one IoT application in either in production or in deployment right now, and that number is growing. We're also seeing the rise of the edge. And if you remember last year, I talked about the last 15 years as being the age of cloud computing, where we had all of the network, storage, and compute moving into the data center because of the economies of scale that existed. And with that, all of the data and analytics were moving into the cloud as well. And a lot of people thought that pendulum was going to swing far into that architecture. But we know in the Internet of Things world that you can't do everything in the cloud. You have to perform some functions at the edge of the network, and you need to perform some functions on the device itself. This has never been more true than in the age of artificial intelligence, where you need that end-to-end ability to move data back and forth recursively. And some of the things that are driving this is we know that over 50% of IoT deployments are network constrained. We don't have the bandwidth to move the data and to move the workloads into the cloud. We also know that 45% of data today is being reasoned over, stored, and processed at the edge. And the reason why that's happening is because of real-time requirements, bandwidth latency, bandwidth costs. There's a variety of reasons why companies and customers need to process their applications at the edge on-prem. And in fact, this market, it continues to grow. We're seeing that in 2022, the market will exceed $7 billion. And what's fueling all of this is the promise of AI, where we're performing actions on the machine, we're performing actions in the network, and we're performing actions in the cloud. So let's take a look at what that looks like and why. So IoT really started with connecting the unconnected. How do we take these machines, these devices, and connect them to the network so that we can take the data off them, reason over that data, and derive some insight? Well, that's been a pervasive trend for the last decade. And what some leading deployments have done is then look at intelligent systems. So how do you then network a group of machines or devices together so that you can start experiencing the benefits of an intelligent system of systems? And now, fueled by AI, we're driving not only intelligence, which is the ability to learn, which is the distinction between something that's smart, which can think, and something that's intelligent, which can learn. Now we have the ability to start driving towards an autonomous future. And this creates a tremendous amount of opportunity for our end customers. And what's happening here, if you think about data, and if you think about Intel's strategy of becoming a data-centric company, these IoT use cases are driving an extraordinary volume of data. The volume of data requires higher levels of compute at the edge, and it's happening because of the bandwidth constraints, and it's happening because of the latency that's inherent in the network. But there's also the velocity of data. Data is moving at a much faster pace. And because of that, we need real-time analytics. And you can imagine on a factory floor, the volume of data that's coming off of a fleet of robots. That data needs to be processed in real time so that that robot can be aligned in a synchronous way with all of the other robots on the manufacturing line. And by introducing certain technologies, we have the ability to synchronize those connected devices within 10 nanoseconds of each other. But those devices also need to be able to operate with humans in a safe environment. And so we introduce technologies like functional safety that allow those robots to then immediately stop in milliseconds if the need arises. And you can imagine the same thing happening in an automobile, where we're driving level 4, level 5 autonomy in cars and trucks. Also requires huge amounts of capability to process vast velocity of data in real time. We're also going to talk today about the variety of data, because it's not just text, it's images, it's video, it's audio. And the variety of data also will impact the technologies we bring to market in the form of things like natural language processing or computer vision, which we're going to go into some depth today. So it's latency in real time that are driving the need for higher performance compute at the edge. And we're also going to see opportunities to optimize workloads across that continuum. So here's an example of a customer that's deploying some things. This is a solution that we did with Cisco. It's a connected transportation. You can see it's light rail transit. Also included in this solution was Davra Networks. And what we're doing here is we're connecting this rail car to itself so that it can learn about how it's performing. We connect it to the track via cameras that are inspecting the track as it traverses on its route. We also connect it to the station, where operators have the ability to reason over a vast, complex transportation network, because these trains don't operate in a vacuum. They have to operate in an environment where they interact with cars and trucks and pedestrians. So by connecting this light rail transit, we have the ability to look at track traffic and rail conditions in real time, which reduces the congestion and reduces auto collisions. We also have the ability with real-time video feeds to improve security of the passengers on that train. And we have the ability to predict when those trains are going to arrive at various stops around the city environment and improve the efficiency of that network. And then, of course, through predictive maintenance and fuel monitoring, we can respond to real-time issues and optimize the efficiency of that train. So let's talk about some investments. I promised you we're going to talk about what we're going to spend money on. These are three areas that we think are tremendous opportunities today, based on real technology that exists today. The first is compute for IoT. So we have historically taken processing capability from the client, and we've applied it to IoT markets. We've taken processing technology from the data center, and we've applied it to IoT markets. That is no longer sufficient. It's no longer enough to provide long life and extended temp on our silicon roadmap. We have to develop silicon for IoT, and we have to develop specific technologies, and we're going to talk about those in a minute. The second opportunity is around workload consolidation. This is an age-old opportunity. It's one that's manifesting itself right now in very real ways, providing you an opportunity to upsell with your customers, to add additional layers of value to what you offer. We'll talk about some examples. And of course, my favorite topic, video and artificial intelligence. And what is underpinning all of this are a set of programs that you can participate in and you can leverage with your customer base called market-ready solutions. And there's a variety of capabilities associated with that we're going to talk about in a few minutes. Let's get started. Compute for IoT. The reason why we need to develop specific technologies is because the market demands it. I gave you some examples earlier. Let's go into some more details. If you look, starting at the left and moving to the right, it starts with a product portfolio that is designed and built for IoT. This includes things like real-time capabilities. We call it time-coordinated computing. It allows for the synchronization of things that are connected in a network. Functional safety, whether it's in a driverless autonomous vehicle situation or in a manufacturing line. Security, embedded below the operating system. And computer vision technologies, technology designed specifically for optimizing computational neural networks from device to cloud and processing as much of that capability at the edge. And of course, technology that's designed for very specific use conditions based on whatever customer industry we're trying to optimize for. And what we're doing now for the first time as Intel is we're starting to build dedicated solutions. In addition to the silicon roadmap, we now are going to be combining CPUs with a PCH. We're going to be designing SoCs that are for very specific use cases. And underpinning this will be the adoption of workload accelerators like we have from several recent acquisitions in Movidius with their visual processing unit and with Altera's FPGA. We're going to talk about how some of those accelerators are driving extraordinary levels of performance with our customer. If you want to learn more about the product portfolio and our strategy in this area, we have a breakout session called the IoT Platform and Product Strategy class, and it's available to everyone. I encourage you to attend. Beyond compute, however, we're also enabling an end-to-end capability. So starting from the left to the right, we're developing not only the client and data center technologies, and we will continue to adopt them into the IoT roadmap, but we're also going to create new silicon, as I just mentioned. In addition to that, we're bringing virtualization technologies and manageability so that you have the opportunity to converge workloads and be able to move up the stack. We're going to supplement that with accelerators. We're going to include memory and storage. We're going to integrate now a connectivity roadmap. And probably the most important thing is a software development kit that provides a single, seamless, and integrated development environment so that you can program to any of these architectures seamlessly and quickly. In short, I don't believe there's any silicon company that has the roadmap and the capabilities to support IoT and AI-led capabilities from thing or machine all the way back into the data center with a tool set as Intel. So let's look at the system efforts that we're enabling here. We talked a little bit about workload consolidation. We're going to go into some more detail, but one of the age-old stories in tech is the ability to do more with What's going on? Larry, I'm in the middle of a keynote.
I thought consolidation. I was thinking consolidation. I have consolidated all of my computing and communications and entertainment devices in this state-of-the-art cart. Check it out, check it out. Here's my cassette player, right? So I can play some music. Got my CD player in case I have another format I need. Yeah. My computer monitor. Check this out now. VHS, baby. State of the art. What do you think?
Larry, I don't know how to break it to you, but that song that you were walking out to is from like 1993.
The Shoop song.
Yeah. Salt and Pepper, I think.
Yeah.
Everything in this cart is also from 1993. All of these things were analog, but they're all digital now, including the actual cart itself. You don't need all of these things because they've all been consolidated into a single device called a smartphone.
Wow, that's a pretty cool thing.
Yeah, so
are you saying that?
What I'm saying is, like, these things are older than the internet.
Well, my friends tell me, I too am older than the internet. Plus, you know, once a year they let me out to come MC this event. Otherwise, I'm in my cave with my great cart and all my consolidated events.
All right, well, I wish you good luck with that. You may have a hard time checking that on the plane, but all the best. I appreciate it.
All right. Me and my cart, we're going to go compute and communicate and entertain. Thank you, sir.
All right. Larry Shoop. Excellent song choice. So here's an example in manufacturing where we're talking about workload consolidation in IoT. And the opportunity here is a great example, but it really applies to a lot of different industries. Here in a manufacturing context, you have a lot of subsystems that are currently analog and operating independently. So you have the hardware and the software all completely disintegrated, whether it's from a PLC, an HMI, vision systems, motion controllers, all of these things currently operating independently. So what you can do is you can actually drive greater efficiency by consolidating the hardware and the software into a common compute architecture, similar to Larry's cart and what has happened over the last 20 years of bringing all of those capabilities onto our mobile phones. That same transformation has been happening in the network for the last several years in the form of network function virtualization, and it's ready to hit every industry. So there's an opportunity here that we talk about in terms of manufacturing. Here's an example of what's happening in smart cities. This is a smart city kiosk from a company called City Beacon, and what is inside here is really a consolidation of a variety of different sensors and workloads. So we've got video cameras that allow for community safety. They also provide parking assistance and can spot for open parking spots. They can tell how long a car has been in a certain spot so that they can automate the ticketing process. There's environmental sensors in here for air quality, for noise detection, so you can hear for breaking glass, screaming, or if there should be a gunshot. There's connectivity in the form of FlexRAN capabilities. So you've got a radio access network. You can provide wireless connectivity for city services as well as for citizens. And the capability to turn that into V2X or vehicle to anything connectivity infrastructure leveraging 5G is available. In fact, this company, City Beacon, has been getting an extraordinary level of demand. In fact, there's a ski resort in Europe that is deploying these city beacons at the ski resort, and they've modified the design so that the top of the beacon is now a flat wireless docking station for drones. And they're using industrial drones for search and rescue when they have lost skiers on the mountain. So you can imagine this as just a really valuable piece of real estate where you can consolidate lots of different capabilities into that footprint. So the way to do this is really simple. First, you bring individual hardware into the same box, gives you an ability to upsell the silicon platform. You can remove the hardware and software dependency by virtualizing these various functions. And you can maximize the efficiency by deploying common technologies across that architecture, like security, or functional safety, or real-time, or computer vision. So lots of great opportunities here to upsell in your customer base and consolidate workloads. So now, let's look at my favorite topic, which is video. And video is just the ultimate IoT sensor. And it's really extraordinary. For the last several decades, it's really been primarily adopted in video security and surveillance solutions. In fact, in 2017, there was 860 petabytes of video surveillance data collected. That's an extraordinary amount, and that doesn't even include what's happening outside of surveillance. In addition, we estimate that by the year 2020, there will be 100 million IP cameras that will ship. In just 2 years, over 100 million IP cameras. And what's cool about this is that there's a flywheel effect that's taking place, because we know that roughly for every 100 cameras, you'll drive 10 network video recorders or gateways that are running Xeon class capability with storage. And for every 10 NVRs or gateways, you're going to drive one video server. It's a really simple metric: 100 cameras to 10 NVRs to one video server. That creates pull end-to-end, and the reason we're winning these architectures is because video is a great use case that really demands an end-to-end computing environment. And it's now hitting mainstream. It's going from security and surveillance to almost every industry. We talked about emergency response and how drones are becoming mobile cameras. But it's also happening in machine vision and manufacturing environments where cameras are being placed on manufacturing lines to spot defects and to do very high-speed sorting. It's happening, of course, in autonomous vehicles where cameras are being deployed in a 360-degree view inside and outside of the vehicle. It's even happening in industries like retail that are using cameras to understand how consumers move around their environment. They're using facial detection to understand the demographics of their customers so that they can better serve them. They're even using cameras to inspect products on the shelf to understand if they're misshelved or if inventory levels are running low. So here's an example of a customer we've been working with for a long time, a world leader in video surveillance. And I wanted to share with you an example of how they're migrating their architecture. So this is Dahua. It's one of our Chinese OEMs. And they've been a world leader in video surveillance, and we've primarily partnered with them historically in the NVR and providing high-performance compute in the NVR to support their media and video encoding, decoding, and transcoding capabilities. And what they've been doing lately is they've been using accelerators to allow for much higher performance of AI capabilities like facial recognition, as well as moving Intel technologies into the camera themselves as they build out an end-to-end architecture. Dahua is currently the camera and video provider for the Olympics. They are also in the London Underground, and in China, they are supporting the Three Gorges hydropower plant. So this is really just, I think, a validation of our approach as we move from a high-performance encode-decode capability in the network video recorder out to the camera, and then allowing AI workloads to traverse inference and training into the data center. And this market is really moving quickly. In fact, the video market itself has been the fastest growing IoT market that Intel's experienced for the last 7 or 8 years. And what it used to be was, the analog era. And this was when analog cameras were capturing footage, and you had to have a physical person viewing that footage to spot something that was going on. But for the past 5 years, due to the tremendous advancements in computer vision and deep learning capabilities, we had the IP era. And in the IP era, we were able to do a lot more with digital content in the network video recorder, and we started to see this growth and proliferation of IP cameras. A great example of this is if you pay attention in an airport, you can see hundreds of cameras in an airport. That's really been a lot of the growth that we've seen over the last 5 years. But where we're going and where this opportunity is going to really translate to every industry is the AI era. And we've just entered the AI era. This is everything from cameras going from 1080p to 4K, so you're bringing in a much richer data set through that optical sensor, leveraging AI algorithms on the camera itself in the network video recorder and in the data center. And a lot of people believe that the GPU is the winner in this market. And I'm here to tell you that that is no longer true. So what you see here is just a really simple assessment of leveraging AI in kind of an end-to-end deep learning architecture. And some people have been leveraging CPUs, high-performance CPU, for inference and performing certain deep learning workloads. And the cost is reasonable, and for many people, it's good enough performance. But what we've seen over the last several years is the rise of the GPU and throwing massive capabilities at these video and computer vision data sets. The problem here is that the performance is great, but it doesn't work at the edge. You're just not going to see the performance per watt per dollar that's going to make it effective to deploy in a city beacon environment or on a smart street light or in hundreds of cameras in an airport. So what we found is that by leveraging an accelerator, if you're looking for a low watt solution, we've got Movidius coupled with a CPU. If you need a higher performance NVR, you can couple an FPGA with a CPU. And we're seeing performance that is better than a GPU at a fraction of the cost. You're going to learn a lot more about this year. This is going to be the year that we bring out a tremendous amount of opportunity for you to take advantage of these AI, computer vision workloads and opportunities. Next month, you're going to learn about version 2 of our computer vision software development kit that is going to give you the ability to write your algos in any framework you like, be able to run those through our tool set and optimize them for any Intel architecture, and to do that seamlessly and very quickly. We're seeing tremendous performance from this, and I wish I could tell you about it today, but next month, please stay tuned. There's a lot coming out. But in addition to the tool set, we're also going to be bringing out a portfolio of pre-tested, pre-integrated architectures over the course of this year and ongoing, so that you have a predictable roadmap of how you can build computer vision-based AI solutions. So one company that we've been working with for 15 years, in fact, we just celebrated our 15-year anniversary and they awarded Intel their Supplier of the Year, is Hikvision, who is a world leader in video surveillance solutions. And they've been taking what they've learned in video surveillance and applying it to other industries. And we're going to take a look at how they're leveraging this with autonomous robots in warehousing environments. They do everything from moving large stacks of product to individual boxes. And they even leverage similar technology in automated parking garages. Let's roll the video and take a look.
Artificial intelligence technology is transformational and has started to be adopted and deployed into the real world in many different industries. Hikvision, the world's leading surveillance company and the leader of IP cameras, has accumulated more than 10 years deep experience in image processing, data storage, video analytics algorithms, cloud computing, big data technology, and now artificial intelligence. This background has enabled Hikvision to start deploying video AI technology into smart manufacturing. One of the driving forces behind smart manufacturing is smart vision. Enabled by Intel's high-performance and stable architecture, Hikvision's machine vision camera combines perfect image processing and high-speed algorithm execution to deliver fast, accurate information acquisition and identification to manufacturing processes. In the sorting process, Hikvision's industrial machine vision camera reads the barcode rapidly and logs the volume and weight information. It intelligently automates the sorting processing with a throughput of 20,000 orders of parcel per hour, therefore reducing the labor cost by 80%. In addition to smart vision, the Edge Intelligence System is the brain that keeps everything moving with fluidity, precision, and control. The Vision Master platform runs the deep learning-based algorithm from multiple sources of video input. And through coordination with various production management systems, it enables a more autonomous manufacturing process. This includes product line monitoring, sorting, and warehousing. For example, it determines in real time the task assignment for the carrying robot fleet and sends the optimized navigation route for robots to effectively move products to their corresponding location. The result is a seamless, efficient, and integrated system.
I really like that example because if you remember, I was talking about how things have gone from connecting the unconnected to intelligent systems and eventually leading to autonomy. And that's a great example of a customer that's gone through that journey and now has autonomous robots that are performing extraordinary things. So, 3 investments that we've talked about and opportunities to engage with technology that's available today, workload consolidation, and video being some key drivers. I also want to talk about the investments we're making in you, because it's super important that we stay aligned, and I think we're finding some really tremendous opportunities to invest in our ecosystem and to be successful together in the marketplace. So really want to talk about kind of go-to-market and how we can align to collaborate with everyone in this room. And there's really 3 areas of Intel investment that I think I want to point out. One is our partner programs. So we are continuing to expand the partner program. Okay, we're adding new types of partners. We're making the partner programs available to OEMs, to an expanded portfolio of ISVs, and to systems integrators. And of course, we're investing heavily in our solution aggregators as a way to give the majority of our partners a path to the end customer and to access systems integrators that will go and deploy those solutions. We also are continuing to scale our market-ready solution program. I'll talk about this in great detail. And we also have an RFP-ready dev kit program, which is accelerating time to market for many of you. And lastly, we want to continue to share our knowledge. And we want to do that through a variety of different ways, and we'll talk through that. So first, let's just talk broadly about the channel. Last year, we trained over 7,000 of our channel partners in a variety of different ways. Some of it was through many live training events. Some of it was through video on demand or online courses. We're going to continue to do that, and we're going to make sure that these are relevant to the areas of growth and differentiation that allow you to be valuable to your customers. You can see we do this across a variety of different partner categories: IoT equipment makers, technology partners, platform partners, solution integrators, and of course aggregators. And we also believe that we have an opportunity to up-level the conversation. Because right now, the burden of technology choice and integration is falling on the end customer. And we need to help to accelerate their time to market. And so we've developed two programs. One is the IoT Market Ready Solutions program, where we are pre-integrating partner content into an end-to-end value proposition around a use case that can scale in the marketplace. And we're also providing RFP-ready dev kits to our solution and system integrators to allow them to respond to opportunities much quickly with Intel and partner content already pre-designed. Let's take a look. The Market Ready Solutions program we launched effectively kind of at the beginning of 2017. And as you can see, we've had almost 200 solutions submitted for approval into this program. It's a pretty rigorous assessment process we have for what gets approved into the program. We approved roughly about a third of them last year. We have about 59 right now, and they really span every industry. You can see here multiple examples of solutions in every one of these categories, and we're going to continue to do that. It's interesting to note that we have over 134 different partners engaged in this portfolio. So it's very inclusive, and we're trying to use this as a way to accelerate your success in the marketplace. We also, as I mentioned, have these RFP-ready dev kits. There's over 20 of them now. They're very specific around a particular use case, and they're focused to solve these domain-specific problems and accelerate the time to market for our integrator and aggregators. They're pre-tested, and they make it really easy for you to develop a response. And you can see here some quotes from some of our partners. I love the Wipro quote. Our competitors are taking 20 weeks to respond to a bid while we do it in less than 8. That's exactly the type of benefit that we're looking to accomplish here. So where these come together is you have the market-ready solutions, which are designed to give you a business conversation with the end customer. You can either incorporate your content and your knowledge and expertise into one of those solutions, or you can take those solutions to your end customer. You can combine that with an RFP-ready dev kit, and through our aggregator program, you now have access to the end customers by industry through the SI channel as well as cloud service providers. You can see there's more that you can learn about this at the URL on the slide. So to wrap it up, the edge is ripe for compute solutions. Customers are demanding more and more. And what we're finding is that the market is moving to us. So higher performance compute at the edge, driving AI workloads end-to-end. We have now accelerator capability to allow you to deliver higher levels of performance at a much lower footprint and cost than competitive offers. We have market-ready solutions and other partner programs to help you accelerate your success and make more money. And hopefully, you're finding programs like this and the opportunities that we deliver to you throughout the year as a great way to make connections and to accelerate your learnings, be part of the journey, and connect with complementary providers. So I want to thank you for your time this morning. Lots of breakout sessions for you to engage in to learn more about the portfolio, about market-ready solutions, about video. I want to welcome Larry Shoup back out to tell us what's going to happen for the rest of the afternoon.
Thank you, Jonathan. By the way, while you were talking, I consolidated
Well
my
done.
workloads. Just
Nice
wanted
job.
you to know. All right.